Our cosmos is vast and fascinating, and with each passing day, humanity advances one step closer to discovering the world around us. Since the invention of space technology, such as the James Webb Space Telescope by the United States National Aeronautics and Space Administration, NASA, space exploration has become easier. The James Webb Space Telescope has proven to be a marvelous creation, transforming cosmologists' viewpoints and the way they perceive the solar system and its entirety. This beautiful innovation was created primarily to observe and analyze astronomical objects in space using infrared light. It is now the largest optical telescope in space. Because of its spectacular infrared resolution technology and great sensitivity, it can see objects as far away as the heart of the Milky Way galaxy. While investigating the contents of the Milky Way galaxy, the JWST discovered a startling finding of a gigantic structure that has astronomers awestruck. What exactly is this massive structure? What impact will it have on cosmological research as we know it? And what actions will scientists take in response to its discovery? Join us as we investigate the massive structure revealed at the heart of the Milky Way galaxy by the James Webb Space Telescope. Previously referred to as the Next Generation Space Telescope, the James Webb Space Telescope is one of NASA's most notable achievements. In September 2002, the multi-billion-dollar telescope was renamed after James E. Webb, NASA administrator from 1961 to 1968 during the Mercury, Apollo and Gemini missions. The design of the Space Telescope was also supervised and developed by two major agencies, the Canadian Space Agency, CSA, and the European Space Agency, ESA, who played distinct roles in the development and deployment of the James Webb technology. It was launched on December 25, 2021 on an Ariane 5 rocket provided by the European Space Agency. The James Webb Space Telescope launched into space from Europe's spaceport in French Guiana on the northeastern coast of South America. Northrop Grumman was the prime contractor on the $10 billion project. At the same time, the NASA Goddard Space Flight Center, GSFC, in Maryland, directed the telescope development, and the Space Telescope Science Institute in Baltimore on the Homewood campus of Johns Hopkins University oversees the powerful space telescope's operation. This enormous infrared telescope features a main mirror made up of 18 hexagonal mirror segments made of gold-plated beryllium, resulting in a 6.5 meter diameter mirror compared to Hubble's 2.4 meter telescope. This provides the James Webb Space Telescope with a light collecting area of approximately 25 square meters, a six-fold increase over the Hubble telescope. When compared to the Hubble, the James Webb Space Telescope observes in a lower frequency range from the long wavelength visible red light through mid-infrared 0.6 to 28.3 micrometers, whereas the Hubble operates and observes in the near ultraviolet and visible 0.1 to 0.8 micrometers, which means that the James Webb Space Telescope must be kept in extremely cold conditions to keep functioning, a temperature of -220 degrees Celsius or -370 degrees Fahrenheit, so that infrared light from the telescope does not interfere with the captured light. This remarkable invention is positioned in a solar orbit close to the Sun's L2 Lagrange point, approximately 1.5 million kilometers, 930,000 miles from Earth, where its 5-layer sun shield protects it from warming by the Earth, Moon and Sun. On January the 8th, 2022, the crew assigned to the Webb mission completely deployed the telescope's 21-foot gold-coated primary mirror, completing the final stage of all major spacecraft deployments required for the space telescopes to commence science operations successfully. The successful completion of all the Webb Space Telescope's deployments is historic, said Gregory L. Robinson, Program Director of the Webb program at NASA headquarters. This is the first time a NASA-led mission has ever attempted to complete a complex sequence to unfold an observatory in space. A remarkable feat from our team, NASA and the world. A few weeks later, on January 24, 2022, the mission crew took a giant leap by activating Webb's thrusters and inserting the Space Telescope into orbit around the Sun at the second Lagrange point, its eventual destination, about 1 million miles away from planet Earth. "Webb, welcome home," NASA Administrator Bill Nelson remarked. Congratulations to the team for all their hard work ensuring Webb's safe arrival at L2 today. We're one step closer to uncovering the mysteries of the universe, and I can't wait to see Webb's first new views of the universe this summer. The James Webb Space Telescope's location provides it with a perfect and wide view of the cosmos, while also allowing the telescope's scientific instruments into optics to remain in a state that would be cold enough for this glorious invention to function and perform standard science as it was designed to do. This space technology also set a milestone on its first mission when US President Joe Biden saw the first complete color image from the Webb for the first time, as well as the sharpest and deepest infrared image of the distant cosmos ever taken. The image, dubbed the Space Telescope's first deep field, depicts galaxy cluster SMACS 0723, which contains hundreds of galaxies as well as the furthest and darkest objects yet detected in the infrared. The next day, on July 12, 2022, further images taken by Webb's cutting-edge scientific instruments were published to demonstrate the telescope's capabilities. These images are the Southern Ring Nebula, WASP 96b spectrum, Stephan's Quintet, and the Carina Nebula. In recent discoveries, a new cosmic creation narrative has come to life. Thousands of previously unseen newborn stars were discovered in a stellar nursery called 30 Doradus and were photographed by NASA's James Webb Space Telescope, which has the ideal equipment necessary for the job. These newborn stars were given the Tarantula Nebula moniker because of the way its hazy filaments appeared in earlier telescopic photographs. The nebula has long been a favourite when researching star formation. The James Webb Space Telescope also discovered background galaxies that were far away, as well as the complex structure and composition of the nebula's gas and dust that supported the nascent stars. The Tarantula Nebula is the brightest and biggest star formation area in our Milky Way's nearby group of galaxies, which is 161,000 light-years distant in the Large Magellanic Cloud Galaxy. It is home to the most massive and hottest stars in the universe. Astronomers focused 3 of James Webb Space Telescope's high-resolution infrared instruments on the Tarantula as a result of this. When observed via the Space Telescope's near-infrared camera, the region seems to be a burrowing tarantula's habitat complete with silk. When you look at the near-cam image, you will observe that the strong radiation from a cluster of huge young stars that shines in the pale blue has cut off the nebula's cavity. Only the tightly clustered outer regions of the nebula can withstand erosions brought on by the stellar winds from these stars, resulting in pillars that seem to face the cluster. These pillars contain protostars that are in the process of formation. They will eventually emerge from their dusty cocoons and take turns reshaping the nebula. Even though the near spec showed that the star was only beginning to surface from its pillar and it still retained a cloud of dust around itself concurrently, the Webb Space Telescope spotted a very young star undergoing that precise process as it was circling and viewing in space. Without Webb's high-resolution infrared spectra, it would not have been possible to see this star formation process in action. Since the dust glows cooler gas and hot stars when it is detected by the mid-infrared sensor of the Space Telescope, the region appears quite different when it is seen at longer infrared wavelengths. Points of light reveal embedded protostars while they are accumulating mass within the stellar nursery clouds. In the nebula, shorter light wavelengths are either absorbed or dispersed by the dust, which prevents Webb from being observed until longer mid-infrared wavelengths can penetrate the dust and expose a previously hidden cosmic environment. One of the main factors that makes the Tarantula Nebula so popular with astronomers is that it has a chemical substance that is similar to the huge star-forming areas seen in the cosmic moon when the universe was just a few billion years old and the formulation of stars was at its peak. The star-forming areas in our Milky Way galaxy do not have the same chemical makeup as the Tarantula Nebula and do not produce stars at the same alarming pace. The Tarantula Nebula is a fantastic illustration of what is occurring in the cosmos as it nears its dazzling high noon due to its uniqueness. Through the use of the telescope's detailed images of distant galaxies from the real era of cosmic noon, the Webb Space Telescope would provide scientists with the ideal chance to study and compare observations of the star formation in the Tarantula Nebula. In a way that has never been seen before, the cosmos is already being uncovered by the James Webb Space Telescope. The amazing invention's quest to rewrite the story and background of stellar formation is just getting started. Even after all of humanity's efforts and years of stargazing, there are still many mysteries surrounding the formation of stars. This is because humans have not been able to see all that has been going on behind the massive cloud of stellar nurseries in clear, sharp images. Yet it is clear that the James Webb Space Telescope is here to put on a show, since it is the largest optical telescope in the universe. All we need to do is unwind, relax, and learn as it reveals the universe's countless mysteries. Let's hear your opinions in the comment section below. Please consider subscribing to the channel if you enjoyed watching the video.